So for part B, we can draw this guy again, a 4-port network. Make a copy. We can paste it here. We're gonna delete all of the other conditions. And we'll move this out of the way for now. So for part B, the question is, what is the insertion loss between ports 2 and 4 when all other ports are terminated with matched loads? So when we have port 1 and 3 terminated with a matched load, this means that V1 minus is 0, V3 minus is 0, and we only have ports 2 and 4. We can, for insertion loss is basically asking what is the insertion loss is essentially asking you introduce a signal into port 2, we call this V2 plus, and measure what comes out of port 4, we call this V4 minus. So we have S41, which is V4 minus over V2 plus, or we can do this the other way where we introduce a signal into port 4. We call this V4 plus, and then we measure what comes out of port 2. This will be V2 minus. So we can have S24, which is V2 minus over V4 plus. So insertion loss will be equivalent to minus 20 log of the magnitude of S41. It can be the magnitude of S41 or S42 or S24. So S42 is here and S24 is here. So I know this is the long way or a difficult way to think about it, but I'm able to see the data S42 and S24. S24 and S42, they are the same. We have a magnitude of 0.3 and an angle of minus 45 degrees for both S24 and S42. So the insertion loss is equivalent to minus 20 log of 0.3. We put that in our calculator, minus 20 log of 0.3. Insertion loss is approximately 10.5 dB.